Okay, so we're in this factoring unit. The first thing we always look for is the GCF, no matter what. So when I look at these problems and the directions tell me to factor, I will always start by looking for that GCF, just in case we have it. If we don't have the GCF, there's other things to do. And so today we're going to learn one of those other things to do if you don't have a GCF. Yes?
Is this our homework?
Well, right now this is the page I want you on, and we'll see how far we get. I don't know what I'm going to assign you for homework right now because I don't know how far I'm going to get with you.
Right.
So I just want to get going, see how far we get, and then I'll make an adjustment from there. Okay. The teachers here at Midlothian call this method Rooftop. So I am going to call it A times C Rooftop, and I have a reason for calling it A times C. It's to help you get started with knowing what to do. So all of the math teachers here, they call factoring this Rooftop method. So I just want to make sure that as you go from class to class, if somebody says rooftop, you've heard that word. I mean, I have never used the word rooftop myself until I came to school here. But since that's what the teachers do here, then that's what I wanted to do with you guys. Okay, this right here, I need to make sure everybody is paying attention to this. This is a quadratic because it's x squared, and this is the generic form for a quadratic. It shows you where the a is, where the b is, and where the c is. A is the number in front of the x squared. C is the constant. It's a number that won't have a variable behind it. So when I tell you to take A times C Rooftop, I'm asking you to take the number that's going to be in front of the x squared or the r squared or the n squared and multiply it with the constant, the number without a variable, and then we'll go from there. And then B is going to be the guy that is in front of the x. Okay, so this is the steps for how we're going to do this. We're going to multiply our A and our C. And then we're going to do that little Xbox thing that we did the other day. What multiplies to give you this that adds to be this. And we're going to go from there. Okay, so I'm just going to kind of walk you through this very first one that's already worked out for you. But it's going to be confusing. And it will probably take 3 or 4 problems before you finally catch on. Okay, so when I look at this first problem here, the first thing I would always want to look for is a GCF. So I'm just going to write GCF question mark. Is there anything that will divide into 2, 11, and 15 besides a 1? No. Cindy, Brooklyn. Do they all have x's? So this does not have a GCF other than a 1. If your GCF is just a 1, we move on. We try to do something different. And so that's what this comes into play today, is this A times C Rooftop. So that's what we're going to call it. And we do this for trinomials. Do you know what I mean when I say a trinomial? 3 terms. So if I've got 3 terms and there's no GCF, the next thing that you're learning how to do is what's called A times C Rooftop. Okay, so A, like I said, is the number in front of the x squared. C is the constant. It's the number without a variable. So you would take A times C, and what is 2 times 15? 30. So if I did this little Xbox thing with you, I'd put a 30 right here. And then what I want them to add to be is the B. I want them to add to B this number right here that's in front of the X. That's the B. So you're trying to think of 2 numbers that multiply to be 30 that add to be 11.
Wait.
And do you know what they are? What are 2 numbers that multiply to be 30 that add to be 11?
6 and 5.
6 and 5. And you'll see that I actually did find them over here, 6 and 5. And it doesn't matter if you put 6 and 5 or 5 and 6. It doesn't matter. Okay, I'm just going to walk you through this. I just kind of want you to watch it, and then we're going to try it. So this was the problem. And then the way we do this is I recopy the first guy. I recopy the guy in the back. But instead of using the 11x, I use those 2 numbers that we came up with. So you know how we said 6 and 5 were the numbers? So I could either put 5x plus 6x or 6x plus 5x. These could be turned around. It doesn't matter. So we're replacing this middle term here with the 2 numbers that we found. We just have to put x's behind both of them.
Wait, Miss Wood?
Mm-hmm.
So we multiply the A and the C and try to get the X1?
Mm-hmm.
X method, all right.
Yeah. So I know right now it's going to be kind of confusing. Once we get going, it'll be better. Then I'm going to look at the very first 2 pieces, and I'm going to ask myself, what's the GCF out of the first 2 pieces? Can you tell me what the GCF is out of those 2? 2x. So that's why you see a 2x pulled on the outside. And then you'd go through this process, 2x times what makes that, 2x times what makes that. So that's where the x plus 3 came from. Then I would look at the back two things. I'd look at the back two things and I'd ask myself, what's my GCF out of those guys? So that's why you see a 5 pulled out right there. And then you'd ask yourself, 5 times what makes that 5x, and 5 times what makes that 15. That's where the x plus 3 came from. One thing I want you guys to know right now, these two things in the parentheses, they have to be identical. If the two things in the parentheses aren't identical, you've done something wrong. So these two things in the parentheses, they always have to look alike. And then as long as they look alike, you just slap that down in one set of parentheses, and then whatever's left over, which is 2x plus 5, goes in the other set of parentheses. And this is A times C rooftop.
So you would double distribute to check?
I would double distribute to check. That's exactly right. So if I were to double distribute, let's just do it mentally. What's x times 2x? 2x squared. Okay, I wanted that. What's x times 5? 5x. Hold it in your head. 5x. What's 3 times 2x? 6x. What would you get if you combined the 5x and the 6x? 11x. So I'm good there. And then what's 3 times 5? So I'm good there. You can always check yourself to see if you're right. If you don't check yourself, then you may not know if you're right or not. But you can always double distribute this and see if you get what you started with. As long as you do, then most of the time you should be correct. Okay, so we're just going to practice a bunch of these because I know it's kind of confusing at first. Okay, first thing I always want to look for, though, is a GCF. Uh-huh.
How did you get x plus 3?
I'll show you. Just watch this one. Is there anything that goes into 6, 23, and 7 besides a 1? Nope. Do they all have x's? So there is no GCF. So then we do another method. And for the trinomials, we do A times C rooftop. So the A is the number in front of the x squared. The C is the constant. So what's 6 times 7? 42. So I'm going to do this little x box over here. And what I want them to add to be is this B, that number that's in front of the x. So I want them to add to be 23.
Would this be prime? Or what would be called prime?
Something will be called prime if it doesn't factor, if you can't come up with any numbers that work. Can you think of something that multiplies to be 42 that adds to be 23? 6 times 7 works to multiply, but they don't add to be 23. Can you think of two numbers that can multiply to be 42 that will also add to be 23? If you're stumped, you could try that thing I showed you yesterday.
Oh.
Do you have it?
Oh, it would be like 12.
2 and 21, right? 2 times 21 makes 42, and 2 plus 21 makes 23. But you know, if you would have started this little thing that I talked to you about yesterday, 1 times 42, do those add to be 23? Nope. Then 2 times 21, do those add to be 23? Yep. So you could always start the little process that I showed you yesterday if you can't think of it. Okay, so this is the way it works. Whatever is the first term, you recopy it. Whatever is the guy in the back, you recopy him. But instead of using the middle guy, you use the two numbers that you just came up with. So since this is a positive 2, I'm going to write plus 2. I just need to put an x behind it. And then because this is a positive 21, I'm going to write plus 21. I just need to put an x behind it. Mathematically, the reason I can do this is, what is 2x plus 21x? 23x is just a different way of rewriting it. So I haven't changed how this is from that as far as values are concerned. I just changed how it looks. This is still a 6x squared. This still makes 23x. And this is still a 7. Okay, then we do this thing where we look for the GCF out of the first two guys. So out of those first two pieces, what would be the GCF? What's the greatest thing that goes into 6 and 2?
That would be 1.
2. The greatest number that goes into 2 and 6 is 2?
What would happen if that one was 1? What's the greatest common factor?
Then I would probably write a 1.
Alright.
Okay, and then do they both have x's?
Yes.
What's the greatest number of x's they both have?
1.
They both have 1. Okay, once I find my GCF, I slap my parentheses back behind it, and I do what I did yesterday. So this is how I'm going to get what was in those parentheses that you asked about a minute ago. 2x times what makes the 6x squared?
3.
3x. And 2x times what makes a 2x? Not x, just 1. See how those look exactly alike? So you just want to multiply it by 1 to make sure that they still look exactly alike. Okay, then I'm going to look at the back two pieces. Can I cover this up? If I look at those back two pieces, you look for the GCF out of those. What's the greatest thing that goes into 7 and 21? 7. Do they both have x's? No, so I'm going to slap down my parentheses. And then I tend to come back and try to figure out if this is a positive 7 or a negative 7 later. But you know how I told you whatever is here should be here? Let's just put it there. Let's just put this 3x plus 1 here, and then take a second and see if it distributes to give us what we wanted. What kind of 7 do you think this is going to have to be? Okay, so let me put the positive there, and I'm just always going to double check. Does 7 times 3x make that 21x?
Yes.
And does 7 times 1 make that 7?
Yes.
Okay, if this for some reason doesn't distribute to give you what you had up here, you've done something wrong somewhere. So these two things should always look alike, but just double check to see if this distributes to give you that. If it does, you're probably good. And then since these are alike, we're going to slap them down in one set of parentheses. And then the thing that's left over goes in the other set. So what's left over? The 2x and the plus 7. So 2x plus 7 goes in the other set of parentheses. Now, I want to double distribute to make sure it just works out. So let's try to do it in our heads. What's 3x times 2x?
6x squared.
6x squared. That's what I wanted. What's 3x times 7? 21x. Keep it there. What's 1 times 2x? 2x. Does 21x and a 2x make 23x?
Yes.
And what's 1 times 7? 7. So as long as it double distributes to give you what you started with, then you're right. And you always do want to look for that GCF first.
Miss Wood,
Uh-huh.
why wouldn't you just, as soon as you got negative, or, sorry, more like that, sorry. Never mind.
Okay. Like I said, it would probably take 3 or 4 problems before it maybe clicks. So let's just try another. Number 3. I will always start by looking for the GCF. It's just sometimes students tend to forget about that. Can you think of anything that would divide into 4, 5, and 6 besides a 1? No. Do they all have x's? No. So there is no GCF. So then I move on. Because it's a trinomial, I'm going to try this a times c rooftop. So I take my a times my c, and what is 4 times negative 6? Negative 24. So that goes up here. And what I want them to add to be is this b, the guy in the middle. I want them to add to be the b, the guy in the middle, which is a negative 5. So I'm looking for 2 numbers that multiply to be negative 24 that also add to be negative 5. A negative 8 and a positive 3. And some of you will be faster at this than others. This is the part about factoring that most students hate. It's just coming up with these 2 darn numbers. Okay, once I've found them, I'm ready to go. I recopy the first guy, whatever he is. I'm going to go ahead and recopy the guy in the back, the minus 6. But instead of using the minus 5x, instead of using that in the middle, I use these 2 numbers that I just came up with. So I'm going to write a negative 8, but I have to remember to put the x behind it. And then this is a positive 3, so I'm going to write plus 3. I just have to remember to put the x behind it. Do you understand where that step's coming from? Kinsey? No. So like if you guys were doing this on your own and somebody put the positive 3x here and the minus 8x here, your work will look slightly different, but your answer will be the same, just flip-flopped. Okay, so then this is when I start covering up stuff. So I look at the first 2 things and I ask myself, what's the GCF out of those first 2 pieces? 4. Do they both have x's?
Yeah.
What's the greatest number of x's they both have?
1.
They both have 1. So 4x is the GCF, and then I'm going to slap my parentheses back behind it. And then 4x times what makes 4x squared? X. And 4x times what makes a negative 8x? A negative 2. Okay. Then I'm going to look at the two things in the back. And what's your GCF out of a 3 and a 6? 3. Do they both have x's? Nope, so it's just a 3. Now, keep in mind, sorry, that's so squished there, whatever is in this set of parentheses should be what's here. So I'm going to go ahead and write that x minus 2 down, but I do have to check myself, because this needs to distribute to give you what you see in the step up above. What kind of 3 do you think this will need to be? Positive. So let's just double check. Does 3 times x make that 3x up there? And does 3 times negative 2 make that negative 6 up there? Then we're good. So this is when whatever is in both of these parentheses, you slap that down into one set of parentheses by itself. And then what's left over goes in the other set. What's left over? And that goes in the other set. And then you can always check yourself by double distributing. So I'm just going to go ahead and do it one more time. What's x times 4x? 4x squared, which is what I wanted. What's x times 3? 3x. I'm going to store it in my brain. What's negative 2 times 4x? Okay. Does a positive 3x and a negative 8x make that negative 5x? Yes. Okay. And negative 2 times positive 3? Negative 6. So we're good. As long as it double distributes to give you what you started with, then you have found your factors. And these are called factors.
How did you do the last part again, the x minus 2, 4x plus 3?
Oh, whatever is in both of these goes in one set of parentheses by itself, and then whatever is remaining, which is the 4x plus 3, goes in the other set. Okay, let's try another one. So I still always look for this GCF. Is there anything that goes into 6, 7, and 5 besides a 1? Nope. Okay, do they all have x's? Nope, so there's no GCF. So I'm going to go to this a times c rooftop. So I take a times my c, and what's a times c? Negative 30. And then, do you know what I want them to add to be?
7.
I want them to add to be the 7. I want them to add to be that b right there. Okay, everybody think of the two numbers. Nobody blurt it out. Think of two numbers that multiply to be negative 30 that will add to be 7. But nobody blurt it out. Okay, have you found it? What is it?
10 and negative.
Good, 10 and negative 3. And the 3 doesn't have to be the negative one because you want them to add to be a positive 7. Okay, so I'm going to recopy my 6x squared. Instead of writing the 7x, can you tell me what I would write instead of writing the 7x? Positive 10x. Minus 3x. Great. And then I just recopy the minus 5 that's in the back. So you're just rewriting the original problem using the two numbers you came up with, and of course you have to put x's behind them. Okay, then I start looking for the GCF out of the first two pieces. What is the greatest thing that goes into 6 and 10? 2. Do they both have x's?
Yeah.
So 2x. So there's your GCF. And then 2x times what makes 6x squared?
3x.
3x. And 2x times what makes 10x? A positive 5. Okay, then I look at the two things in the back. What's the greatest thing that goes into 3 and 5? 1. Do they both have x's? No. If the only thing that goes into them is a 1, let's go ahead and write that 1 down. And then remember, whatever is here should be here, and they should look exactly alike. So if this is 3x plus 5, this one should be 3x plus 5. Now, what kind of 1 do you think this would need to be? A negative. So let's just double check. Negative 1 times 3x, does that make that negative 3x?
Yeah.
And negative 1 times 5, does that make that negative 5?
Yeah.
Okay, so then this is when I take what is ever in both of these parentheses and I slap it down in one set of parentheses. And then I take what's left over and I slap it in the other set. What's left over? And there it is. And then I can always double distribute just to make sure it gives me what I started with. So you can always check yourself. How are you feeling?
Pretty good.
Pretty good. You want to try 5?
Siri, if she can do it for me.
I want to see if you can do this last one.
X squared plus 25x.
Yes,
plus
ma'am.
24.
Can you come here?
Okay.
Here's a free.
Dude!
She keeps telling me all these pictures. I don't know who.
Miss Wood, I will never do my homework again. Siri just gave me the answer.
Can you block it?
I told you that.
I would block it.
Who has clothes on?
Say, I don't know you. No, say, yeah.
Yeah. I would just block it, and then he can't contact you anymore. So.
Yeah, thank you, Siri. Oh.
Tyler, did you try it?
Siri tried it.
Oh, wait.
I wanted
X is
Tyler
W,
to try it.
right?
I'm sorry, what?
X is same as W.
Yeah. Instead of X's, they're W's, but it doesn't really matter. I mean,
Miss Wood?
if you're using X's, that's
You
fine.
know if you could factor 24 and 25? Like, if 24 is on top and 25 was on the bottom.
Where'd you get a 24?
Right here.
Oh, you're trying to do your homework.
Oh my goodness, oh my goodness, oh my goodness.
Yeah, they always have to look exactly alike.
Which one did I do wrong?
Okay, whatever this is, that has to be. So if this is W minus 1, he wants that to be W minus 1. But to get the negative 3, yes. So like, whatever you calculate is but because it's supposed to give you a negative 3W, then now we have to. That way negative 3 times W, and then the negative 3 times W.
Oh, okay.
Yeah, those two things in the parentheses always have to look exactly alike. They can't be different, like signs, nothing.
Oh,
Okay, to multiple be positive, they can be positive, or they can be negative.
So Tyler, you can't play at all if you're on side.
And they get a 3 and a negative 11. So they can either both be
Doesn't
positive
matter
or
if
they can
block.
both be negative.
Yeah. What is that?
What you have? What is that thing with
I was opening my spirit box today.
From there, it doesn't look like
It says the directions in
Star Wars.
Spanish. What am I supposed to?
Oh yeah, I remember.
it looked like Gandhi.
The purple.
Where is the directions?
I was gonna get exact, but look, it writes purple too.
Yeah, what is alphabetico?
Right.
I really thought it was Gandhi.
That's not.
Everybody calls it
But that one.
Rashi.
I said the directions.
And they call Christians the
Into the following.
Because it says then you
I
be
remember.
11.
I obviously got that. I know, and this one down here says answer one question. But I don't.
Gorillas are fast, dude.
They've been around
So you can have that process.
They run pretty
Where you
fast.
start with one that means what makes
Look at your Do you know what this means?
Okay, but do those two numbers add to be negative 14?
Well, I guess.
How
Now, the
fast
multiply
do
be a
gorillas
positive, they can both
run?
be negative 2. Well, those also, those add to be negative 14.
They, I
Then
am
I'll go to 2. 2 doesn't go in. Then I go to 3.
Top
3
to
times
25 miles per hour.
Oh crap.
Promise.
A human can't run.
In excess, they're going to
They would have to be
Well, if I have to look at the. Yeah, well, gorillas running
How fast
25.
can a human run?
Did we do an
That's
answer?
my check.
Okay. On this one, did you guys get your numbers to be what multiplies to be 33, that adds to be negative 14, to be a negative 3 and a negative 11?
Yeah.
Okay, so I'm going to work it out one way, but your answer might look different than mine. So I'm going to have a minus 3w and a minus 11w, and then the plus 3 in the back. Some of you might have these switched. If you have these switched, your work will look different, but your answer will be the same. My GCF out of those two is just a w, and I'm left with 11w minus 3. My GCF out of these is just a 1. I know these two things have to look alike, so 11w minus 3. But in order for it to multiply to give me what I have up there, it's going to need to be a negative 1. And then 11w minus 3 goes in one set, w minus 1 goes in the other set. Is that what most of you got? Okay, you got several papers today. I want you to make sure you hang on to everything. But what I'm going to give you for homework is this page here that says Factoring Trinomials Part 1 assignment. But I'm just going to have you do 4 through 8. So I know some of you have already got started.
I had 1, 2, and 3.
I know.
That's why you decided
So, no, that's not why I assigned it to you. I have a reason, but that's not why I signed it. So I want you to keep all the papers because I want to come back to those other notes tomorrow. But on this assignment, I just want you to do the 4 through 8.
Miss Wood, what
What?
was the answer?
I didn't
to the one
get
we just
that.
did? I think I got it wrong.
Oh, I should, this 11,
No, didn't
I
get it right.
didn't get that paper.
you guys didn't get those? Okay. Well, I didn't pass them out. I had other people.
That's
Get my boxing game back.
Is this just this one that you didn't get?
Oh, sorry.
So 4 through 8.
I deleted it to get these.
Alright, we're all wearing this in the hall.
I thought people was going to be better.
Do it.
Disappointing.
Are you gonna go on?
I don't know. I already told you. I know. Chris, I don't know.